Hi everybody, today we're going to look at solving exponential equations. So maybe you saw in a previous video that I did solve some exponential equations that were one-to-one, but today we're going to make that even bigger. So let's go back quickly and look at the one-to-one property. It says a to the u equals a to the v means that u is equal to v. So when I can make the bases the same, then I know that the exponents are also going to be equal, and that's really helpful. That could be really easy, like 5 to the x equals 5 to the 6, which immediately says x is equal to 6. Or sometimes it can be a little bit more sneaky, like 7 to the x is 2,401. What I would probably initially do with this is kind of look at powers of 7. We know 7 squared is 49, so maybe try 7 cubed, which is 343. So try 7 to the 4th, and it says 2,401. So that lets us rewrite this as 7 to the x is equal to 7 to the 4th, and x would be equal to 4. So let's make that bigger. Here I have 4 times 5 to the x is 600. So what we want to do is get the exponential part, the 5 to the x by itself. So we would divide by 4. This says 5 to the x is equal to 150. Now, if you try powers of 5, you get 5 squared is 25. You get 5 cubed is 125, and then you do 5 to the power 4, and you get 625. Now, that means we skipped right over 150. So 150 is not a perfect power of 5. So what we do when that happens is we are going to borrow one of our properties of logarithms. So there's this one that's the power rule, which says the log base b of m to the p is p times the log base b of m. What I tend to do is use that with natural log. So if I have natural log of m to the p, I have p times the natural log of m. Why that's important is it brings the power down, and right now x is the power, and that's what we're trying to solve for. So I'm going to take the natural log of 5 to the x and the natural log of 150, which says the x comes in front. I have the natural log of 5, that's natural log of 150. So I can divide by the natural log of 5 on both sides, and that says x is the natural log of 150 over the natural log of 5. It is very tempting to try to cancel the natural logs or try to divide 150 by 5, but you can't do it. You have to leave it this way. Now, in your homework or quizzes, whatever that you're doing, it may say give the exact answer and give the approximate answer. This is the exact answer. I didn't do any approximation, but then you can put it in your calculator and we'll get that it's approximately 3.113. Watch how many decimal places it tells you to put in. Also watch how it goes into your calculator. You might notice that it puts a parenthesis and you need to close it. So I'll go to the calculator eventually and show you that. Let's look at this next one. I have 1/3 to the x is equal to 27. Now this one, we're back to looking at it and deciding, do I need to use this natural log or can I just change this to a power? And I noticed that 3 and 27 look kind of connected. So I'm going to rewrite this. I'm going to say 1/3 is 3 to the negative 1 to the x. And I'm going to say 27 is 3 cubed. Then I have that 3 to the negative x is equal to 3 cubed. That says negative x is 3 and x is negative 3. So one of the really important parts here of you solving these exponential equations is knowing what to do when and having a strategy. I think that's a big part of math in general, is having that analytical mind that goes after problems and looks at the best way to solve them. So here's another one. I have 1/8 to the x plus 2 is 8 to the 6x plus 11. This looks a lot like the last one. I'm going to write 8 to the negative 1 to the x plus 2 is 8 to the 6x plus 11. I'm going to distribute the negative 1. So I have negative x minus 2 as my exponent on the left, and then still I have the 6x plus 11 on the right. Now that the bases are the same, I get to drop them. Negative x minus 2 is 6x plus 11. Let's move the x's to the left, so I'll subtract 6x. It says negative 7x minus 2 is 11. Let's move that 2 over. So negative 7x is 13. And then lastly, divide by negative 7. So x is negative 13 over 7. I would leave it like this. This is exactly the answer if you put this in the calculator. If you put it in the calculator, you get a really long answer, and it does kind of repeat. You see it's negative 1.857142857, right? It's going to start over. Don't do that. Leave it as a fraction. That's the best answer. So the next one says e to the x is 9. I want to use that rule again of using the natural log, and we're going to do that on both sides. So the natural log of e to the x is equal to the natural log of 9. But when we look at the natural log of e to the x, this is asking what power of e is e to the x, and it's just x. So I want you to get used to the idea that natural log and e kind of cancel each other out, and the x just comes down all by itself. So this says x is the natural log of 9. I'm going to show you that in the calculator, so I'm going to just type in ln, I'm going to put 9, and you can see it gives the approximation. So I have 2.1972. Let's quickly compare that to a different calculator. When I hit natural log, see how it pops a parenthesis? So when I put in the 9, just get used to closing it if you have this type of calculator. Again, you get the 2.1972, so same answer, just different calculators. So let's write here, x is approximately 2.1972. My next one says 2e to the 7x is 150. You want to isolate the e before you apply the natural log. So let's start by dividing by 2. E to the 7x is 125. Then we take the natural log of both sides. So natural log of e to the 7x is natural log of 125. Natural log of e, it goes away. I have 7x that comes down. Natural log of 125. Divide by 7, divide by 7. So x is exactly the natural log of 125 over 7. Let's put that in our calculator, get an approximation. Let's try it here. I have the natural log of 125. Super important that you close the parenthesis before you say divide by 7. This gives us an answer of 0.68975, but I'm going to round that up to 0.6898. Now watch, if I go back to ln, and I put 125 and I forget to close the parenthesis and I divide by 7 and push enter, totally different answer. So really be careful with how you put this in. If you were looking at Desmos instead, I just type in ln and then I had 125, and then when I hit divide by, see how the whole thing jumps to the bottom? So the whole thing being on the bottom, I can see this is the right way to do it. So we're going to put 0.6898. So let's continue to make this a little bit bigger, add steps to it, because I want you to think about order of operation of how do I come about getting this e isolated, and we want to do it the easiest way. So the easiest way to take this 12e to the 6x minus 2 plus 11 equals 203 and solve for x is to isolate the e and go about it without introducing fractions too soon. So I'm going to start by subtracting 11 from both sides. I have 12e to the 6x minus 2 is equal to 192. Then I'm going to divide by 12, divide by 12. This says e to the 6x minus 2. 192 over 12 is 16. We got lucky. Now I'm going to take the natural log of both sides. That's going to leave me as 6x minus 2 on the left, natural log of 16 on the right. We need to move the 2 over, so 6x is equal to the natural log of 16 plus 2. You cannot add the 16 and the 2. Maybe putting parentheses around the natural log will help you separate that so that you're not thinking to add 16 and 2. Then the last thing is divide by 6, divide by 6. So x is equal to the natural log of 16 plus 2 over 6. Again, I'll put those parentheses there. This is the exact answer. Let's do this also in the calculator, and I can show twice again. Let's start in Desmos. So I'm going to put a parenthesis to kind of start the whole thing off. Here's natural log of 16, and then I'm going to say plus 2. Close the parenthesis. That says this is my numerator. I'm going to divide by 6. I have 0.7954. If I tried to just type the natural log of 16 plus 2 and then hit divide by 6, see how it only did the 2? So you have to put those parentheses to establish the 16 and the 2 are connected in the numerator. Let's get rid of that. Let's go to the TI. So I have to do the same kind of thing here. I have to say parentheses, natural log 16, close the parenthesis, add the 2, close the parenthesis for the numerator, divide by 6. Then when I hit equal, you can see the 0.7954. So let's put that in. I think it's really good that we're doing both here. The exact is great because we like to have things that aren't rounded, but the approximate is good too, just to have some feeling of how big is this number, and I think that's important to have that perspective of what does this look like, so it's good to do both. And so here's another one, 6 to x is 300. We're going to use the same strategy, even though the base is 6. I'm going to use the natural log of 6 to the x is equal to the natural log of 300. What happens is the x still comes down. That's from the power rule. I have the natural log of 300, and then I divide by the natural log of 6 over the natural log of 6. So exactly, our answer is the natural log of 300 over the natural log of 6. And then approximately, this is 3.1833. Let me show you something else with this. I think it really helps to visually see what are we doing. So we're looking at f of x equals 6 to the x, right? We have this function, and we want to know when this is equal to 300. So I put the function 6 to the x, I put 300, and I'm looking at this place of overlap. I know you don't see it right now, and we could scroll in, but you're going to have to scroll a lot to get to 300. So I'm going to go to the settings, and I'm going to change the y to say it could start at 0, and I want to go bigger than 300, so maybe 350. And then I'll step by 50. So this way, I can kind of see everything, and then I can tell that this overlaps right here, and there's that 3.183 we talked about. So I like this visual representation of saying, what are we doing when we're setting things equal to each other? So let's try a couple more of those just to make sure we really have the hang of it. I have 4 to the 2x is 3,800. First step will be take the natural log. The 2x comes in front, I have the natural log of 4, and then I have the natural log of 3,800. You are trying to isolate the x, so what are you going to do? You're going to divide both sides by 2 and the natural log of 4. Divide by 2 and the natural log of 4. So this is x is equal to the natural log of 3,800 over 2 times the natural log of 4. I want to show you how to put this in the calculator. I know I've shown you a few times already, but it's so important to watch the little steps. You need parentheses around the denominator if you are using like a scientific calculator or even a graphing calculator. You really have to show the calculator the order of operations because it doesn't know it. I'll go to Desmos first so we can see what the answer should be, and then I'll go to the TI to see how there's a little difference in how you put it in. So in Desmos, I start with typing natural log, I put 3,800, I hit divide, and it pushes everything to the bottom. So then I can put 2 natural log of 4. And I see I get about 2.9729. Let me show you in the TI and show you how to get the same answer from a different kind of calculator. So first, let's hit natural log of 3,800. Close the parenthesis because we know to do that, but watch if we do divide by 2 natural log of 4. Close that parenthesis. We get this number 5.713. If I add my parentheses like I'm supposed to, natural log of 3,800 divided by parentheses 2 natural log of 4, we get the 2.9729 that we're supposed to. So it's kind of tricky. You really have to know the order of operation of whatever technology you're using, and just kind of think if I have more than one thing in the numerator or more than one thing in the denominator, they need parentheses in order for us to get the right answer. So this was x is about 2.9729. Technology is great, but it's as good as what we tell it to do, right? So you really have to pay attention there. So let's go a little bit bigger. And notice this time I have 5 to the x plus 3 is 8 to the x minus 2. This is a lot bigger because two things are happening. Like first, 5 and 8 aren't the same base, and I can't turn them into the same base. But now I also have x's in the numerator of both of these. Luckily, the first step is the same. I take the natural log of both sides. Then the exponent comes down. I'm going to put a parenthesis with the exponent because I don't want to lose anything. So now I have x plus 3 times the natural log of 5 equals x minus 2 times the natural log of 8. I need to solve for x, so I am going to start by distributing. I'm going to do x times the natural log of 5 plus 3 times the natural log of 5. That's going to be equal to x times the natural log of 8 minus 2 times the natural log of 8. Our goal is to solve for x, so let's get all the x's together. Let's get all the numbers together. So I'm going to leave the x natural log of 5 on the left, and I'm going to bring the x natural log of 8 over with it. I'm going to move this 3 natural log of 5 to the right. It will become negative, and I still have this negative 2 natural log of 8. The big key to solving this one is to factor out this x. I have x in both terms. I'm going to take it out. That gives me the natural log of 5 minus the natural log of 8. Then I have negative 3 natural log of 5 minus 2 natural log of 8. Last step, x is equal to negative 3 natural log of 5 minus 2 natural log of 8 over natural log of 5 minus the natural log of 8. Now you can tell this is big and it is complicated. You need parentheses around the numerator. You need parentheses around the denominator. I would do that in any calculator you grab. So I don't care if you're grabbing Desmos or a TI or a Casio, whatever you're doing, lots of parentheses on this one. After I put all that in, I got x is approximately 19.1215. Let's try one more of those. This one kind of interesting because the exponents are equal. I have 7 to the 5x minus 4 equals 9 to the 5x minus 4. No matter what, you know, first step is take the natural log of both sides. That's going to bring the exponents down, which you know I would like to see in parentheses. So I have 5x minus 4, natural log of 7 is parentheses 5x minus 4 times the natural log of 9. Then I'm going to distribute 5x natural log of 7 minus 4 natural log of 7. That's going to be 5x natural log of 9 minus 4 natural log of 9. Then we say put all the x's together. So 5x natural log of 7 minus 5x natural log of 9. I'm going to move the negative 4 natural log of 7 to the right. Now it's positive. So I have 4 ln of 7 minus 4 ln of 9. I take out the x. I only take out the x. I know the 5 is in common, but I don't want to solve for 5. I want to solve for x. So leave the 5 in. I have 5 natural log of 7 minus 5 natural log of 9. That's equal to 4 natural log of 7 minus 4 natural log of 9. Let's go ahead and put that in parentheses now. Kind of think ahead where we're going. I'm going to divide both sides. So both sides are divided by 5 natural log of 7 minus 5 natural log of 9. My answer exactly is 4 natural log of 7 minus 4 natural log of 9. Big parentheses, right? So I'm keeping track of that. Bottom, 5 natural log of 7 minus 5 natural log of 9. Let's do this one together. I'll show you this one as well. I'll do this in Desmos so you can see it. So I'm going to start with parentheses, 4 natural log of 7 minus 4 natural log of 9 divided by parentheses, 5 natural log of 7 minus 5 natural log of 9. This came out really nice. At the end, it says this is equal to 0.8. So I hope seeing all the little steps is helpful as we're doing this. I would say always as you're watching the videos, kind of try it, go along to make sure you're getting the same thing in your calculator that I'm getting. And hopefully you're seeing the strategy here is natural log, natural log, natural log. Good luck.